Our main strategy was change things to sine and cosine. I'll draw the line. Can you see that they are already sine and cosine? Second part of our main strategy was get a single fraction on both sides. It's already a single fraction. So you are completely stuck in this question if you decided to use the main strategy. There's nothing you could do with the main strategy. It's already been done for you, and it doesn't work out. Then I would look, do you have anything squared? Because if you have things that are squared, you can change them using the Pythagorean identities. Again, this question, there appears to be nothing you can do. If you get stuck, okay, I'm going to write stuck here, because you will get stuck. And if you get stuck, there are two main strategies that I want you to think about if you get stuck. One of them, which I'm going to list first, but does not work here, is factor. If you have a difference of squares, can you factor? That might make your life easier. This one doesn't. So it's not really helpful. I'm being extra non-helpful to start this question. I'm so sorry. Okay? But the second strategy that you are allowed to use, I give it a special name. I named it myself. I call this strategy build the other side. Technically, you do that by multiplying by 1. If you get stuck, take your answer and multiply it by 1. Which doesn't make much sense, does it? But it's going to. So the build the other side strategy says this. If it's not working for you and you can't factor, well, I could multiply by 1 and I could at least get something the same. I could either choose to get my denominators the same, or I could choose to get my numerators the same. Normally people like to get the denominators the same, so I'm going to be like, well, this denominator is a 1 plus cos theta. This denominator is a sine theta. So if I multiply this side by sine theta over sine theta, and this side by 1 plus cos theta and 1 plus cos theta, then in my next step on both sides, and I'm not even going to multiply it out, I'm just going to leave it factored. Can you see that at least my denominators would be the same if I did that? I'm multiplying by 1 because what's in the blue is equal to 1. Okay? I'm multiplying by 1, and I've at least made my denominators the same. Now let's look at what happens to our numerators. This side's easier. Sine theta times sine theta. Can you see that that's going to be sine squared theta? And 1 plus cos theta is going to get multiplied by 1 minus cos theta. That's a difference of squares. Make sure you're recognizing differences of squares quickly and easily, because they will make your life go a lot faster. So this is the difference of squares. If I multiply that out, it had to have been 1 minus cos squared theta to begin with. Now, I haven't proven anything yet, but at least my denominators are the same. So now I only have to worry about my numerators. If only there was a way that I could change something in my numerators now to make them the same, and now they're squared. So now we can use our squared formulas. And can you see that you can get 1 minus cos squared with one mental math manipulation? So you are allowed to just change that to sine squared right away. We're done.
Mix it up.
So what started off as impossible became possible with build the other side. I'm not going to do B right now. It's a bad day for seeing things. Turn to page 620, and I'd like you to copy down now advanced strategy. Okay? And I'm going to do a little bit of numbering here. Bullet 2 and 3 were the very first main strategy we used. Changing trig functions to sine and cosine and combine fractions by getting a common denominator. In other words, get a single, right? I always talk about this one. Trying to get a single fraction on both sides. That's our main strategy. Okay? The second strategy that we were introduced to today, okay, was and I'm going to put this one in 2 as well. Like sometimes you could look at the other side and go, like the cotangent one, you'd be like, hey, I can change my cosecant squared to cotangent squared. So if I know what's on the other side and what I want, sometimes the other side is a hint for finding a quicker proof. And usually that hint means that you're not changing to sine and cosine because you're going to use one of the other Pythagorean identities. So if you have a tan squared theta, before I change it to sine squared theta over cos squared theta, I'm going to think maybe my Pythagorean identity is better. Not always. Sometimes you'll still have to go back to strategy number 1, but sometimes it is. Okay? And then when you get stuck, strategy number 3, either factoring or build the other side, is the strategy you need to use if nothing's working for you. This is probably what you need to do. Okay? When we build the other side, often we are doing something called multiplying by the conjugate. And the word conjugate is a math word for differences of squares. That if you have the same binomial, but a different sign in between, those are conjugates. And the problem with the strategy of multiply by the conjugate is most students don't know the word conjugate very well, don't really know what it means, and so it's very hard to remember a strategy that you don't know what the word means. So I changed it to build the other side, because that is intuitive and easier to remember. But it's the same thing as multiplying by the conjugate and multiplying by 1. And with this, on your proof sheet, you can go all the way up to 45. I think either 46 or 47, you don't have to worry about, but you can go all the way up to 45.